I wanted to say a little bit about alternate ways to express conditional statements and also talk a little bit about biconditional statements and how you prove them. Okay, let's start with a conditional statement, P implies Q, and suppose that that happens to be true. Then the moment P is true, then Q has to be true as well. So you can think of that somehow as P is causing Q to be true. The truth of P somehow forces the truth of Q. Now there are a number of other ways of expressing the same kind of thing, and I wanted to write them down and have a look at them. So I've written things like, A if B, A only if B, A is sufficient for B, A is necessary for B, a whole bunch of things like that. I claim each of those is either A implies B or B implies A. So I want you to figure out which. So look at this one, A if B. Okay, A if B. So which one is essentially causing the other one to happen? It's saying that A happens if B happens, and so somehow the moment B happens, A has to happen, and therefore that's the same thing as saying B implies A. On the other hand, what does A only if B mean? It's saying A can happen only if B also happens, so essentially that's saying the moment A happens, B must happen as well. So that's really saying A implies B. So even though the words look very similar, A if B, A only if B, they actually are converses of each other. And so there is really no logical connection between A if B and A only if B. Now we can combine those two into a single statement when we say A if and only if B. That means A if B and A only if B. So in other words, it's saying B implies A and A implies B, and so that's what we call the biconditional statement, and that's written like this. A if and only if B is written like this in symbols, and it means A implies B and B implies A. Okay, now let's look at a few more examples. A is sufficient for B. What does that mean? Well, it means that A is just barely enough in order to force B to be true. That's what sufficient really means. And therefore A is causing B, and so that's the same thing as saying A implies B. But if we say A is necessary for B, we're saying that it's necessary that A happens whenever B happens, and therefore B is somehow causing A to happen, so that's the same as B implies A. And so you see they really have opposite meanings, or not opposite, but one is the converse of the other. So if we say A is necessary and sufficient for B, that's expressing both of the previous two, and so that's another way of saying the biconditional. That's the same as A if and only if B. There are others. Let's see. We also have A whenever B. So A whenever B means what? It's saying A happens whenever B happens. So in other words, once B happens, A has to happen, and so that's the same as B implies A. And what about A only when B? A happens only when B happens. So in other words, the moment A happens, B must have happened as well. So that's the same as A implies B. I guess the word whenever is the same as if. So this one is really the same as A if B, which is B implies A. And only when is the same as only if. So it's A only if B is the same as A implies B. Okay, so I wanted to go over those with you because a few assignments ago I gave you some of these to look at, and I sort of had the impression people were guessing And so I hope that's a little bit more clear now. I just wanted to say a few words of how you write a proof of the biconditional proposition P if and only if Q. Just wanted to point out that there are typically going to be at least two paragraphs. One paragraph for the proof of P implies Q, and one for the proof of Q implies P. So typically, most of the time, you have to do them separately. So in your proof, you would first say, we first prove that P implies Q is true, and then you would complete the proof of P implies Q, and you would end the paragraph by saying, thus P implies Q is true. Then you start a new paragraph, indent, start a new paragraph. We now show that Q implies P is true. You would complete the proof of that, and conclude by saying, thus Q implies P is true.